welcome everybody to the EnergyTech University Prize West Region Explore Event. A big congratulations to all the teams who will be presenting today and for making it to this phase of the competition. My name is Eric Smith. I'm the Executive Director of the University of Arizona Center for Innovation. And unfortunately for all of you, I will be serving as your MC for this event. I want to thank the Office of Technology Transitions for this opportunity to host today's event, as well as Exponential Impact, Portland State University, University of Washington, and Launch Alaska for co-hosting this event with us. As you can see, we're trying to build a nationwide network of support, and this event is just a small representation of that. We certainly cannot do this without the kind, generous support from our judges. Everybody that we bring into competitions like this are high caliber individuals, a deep bench of experience, and everybody's time is limited. So thank you so much for joining us today. We have Michael from Washington Clean Energy Testbeds, Clean Energy Institute, University of Washington. We have Morgan with Omni. We have Ted with the McGuire Center for Entrepreneurship, Ryan with US Bank, and Sarah Jane with Deloitte. So thank you again to all of our judges. Hopefully, in addition to the role that you'll play as a judge, you'll have a little fun, and maybe we'll explore some new technologies here that we haven't heard of. All right, now's the time we've all been waiting for. So please see this pitch slide, or this slide for the pitch order. It'll be a rapid pace competition. Teams will be pitching for 5 minutes, followed by 5 minutes of Q&A from the judges. Casey will let them know when they have 1 minute left in the chat, and we'll be keeping time. So if I can make 2 suggestions. One, take a screenshot right now of the slide that I have up. If you are a presenting team, I will do my best to make sure that we're calling the team and the team that is on deck. And then make sure that you are paying attention to the chat. You can indeed pull up the chat after you share the screen, where Casey will be letting teams know when they have 1 minute left. And I believe that we will be doing that for the Q&A as well. And now I can see everybody's faces here. First up, we have renewable marine energy for coral reef survival on deck is Future Heat.
Hello and good afternoon. We are Future Heat, providing electrification solutions focused on cold climate air source heat pumps. Our team is comprised of Michael Reynolds, myself, the captain and CTO, a chemical engineering master's student at the University of Utah with over 5 years of experience in energy and utilities consulting, and RT Williams, our CFO, chemical engineering PhD student at the University of Utah with over 3 years of experience in energy and design consulting. The issue that we face in the Wasatch Front of Utah is related to both climate change and winter air quality. The climate change that we all experience is worsening droughts in Utah and leading to suffocating inversions throughout the Salt Lake Valley. Carbon reduction targets for our state are forcing the need for energy practices to adapt, but fossil fuel heating in the form of traditional natural gas furnaces and natural gas water heaters is not sustainable and won't achieve those carbon reduction targets. So we've focused on cold climate air source heat pumps, which are an efficient variety of heat pumps that use electric energy to both heat and cool. The market narrative around air source cold climate heat pumps has been that they are more expensive and that those do not justify the incremental cost. The Building Technology Office reports an average incremental cost of about $1,350 for a cold climate air source heat pump over a furnace. The Northwest Energy Efficiency Alliance has published studies from market research showing that decision makers are willing to pay incremental costs for heat pumps, provided they are aware of the technology and its merits, and the simple payback is reasonable. We have found through our work with our partner, Give Group, that all electric is not more expensive. Give Group is a local developer that designs, builds, and operates low-income, all-electric multifamily apartment buildings. And their publicly available bid sets show that their electric designs are more efficient and less expensive. Diamond Rail came in at $133,000 less than an identical building with a gas furnace and gas water heaters. So the problem we see is that sustainable heating and cooling have a perception as cost intensive, Ignorance and lack of knowledge of the benefits is leading to a lag in the adoption of this technology here, because comparative analysis is split between firms and providers, so they can't make their decision. So the solution is a consulting service that specializes in electrification strategies, particularly cold climate air source heat pumps and water heaters adapted to the Utah Wasatch Front market. We provide energy modeling, economic analysis, connections to construction and contractors, and monitoring and verification services throughout the life of the project. Our business model provides services including conceptual design of electrified HVAC systems using energy modeling and economic evaluation, connections to local installers, contractors, and developers, and continued support through the system, through the life of the building, including energy certifications and awards. Our price structure will charge a fixed rate for initial consulting and for energy modeling, hourly consulting rates for labor on design build, and a tiered subscription service based on the client's needs for continuing M&V. We believe we have an amazing market here in Utah. Our real estate market is booming. Research from the University of Utah indicates that about 30,000 residential permits were issued in each 2020 and 2021. And we see each residential permit as an opportunity to push a heat pump into the market. Of that $6.7 billion in the market size in the 4 counties in the Wasatch Front, we can capture about 30% of that developer access to give us an available market of about 1.4 billion. And 5% of those devoted to consulting gives us about a $69 million available market, which we will achieve by working through our existing partners with the GIVE group, the Industrial Assessment Center, which we have on campus doing energy analysis to find more clients, and Rocky Mountain Power, our electric utility, who wants to push electrification in this region. And we will work through these existing partners to reach new customers and through professional engineering organizations. Our competitors we see as natural gas utilities for whom electrification is a threat. Our state is very fossil friendly. We also see competition from energy modeling companies who have to be convinced that we bring value to their table. But our advantage is that we fuse economic analysis at every step. We're asking for $2,500 to continue our travel, achieve the licensure and certifications we need, and for capital for software. But we know that electrification of using cold climate heat pumps will benefit city and state officials in their carbon goals. We will all breathe healthier air here in the Wasatch Front. Developers will save cost and streamline their schedules, and low-income owners will pay less in their utility bills. Thank you. We are Future Heat.
All right, well done, Future Heat, and right on the money with time. We're going to go for 5 minutes with Q&A from the judges. Judges, feel free to unmute and ask away.
So I had a quick, this is Ted. I had a question. So your revenue model is that you guys are going to consult to big developers or individual homeowners or big commercial buildings, and whoever that is, have you figured out, so if I'm an individual homeowner, what's the cost savings versus how much I'm going to pay you? Like, why would I want to pay you? I mean, what's the payback before I make up what I'm spending to have you tell me to put in a heat pump?
Let me show you a case study from my home. So this is my home in South Salt Lake, 1,600 square foot attached townhome. And I did this for my home, and my payback is about 12.2 years. I live in a house that has 2 walls with essentially infinite insulation, so I only lose heat at the front and the back because I have 2 attached neighbors. And for me, that results in a payback of about 12 years. But I don't use very much gas to heat my home. In fact, homes that use just twice the amount of gas that I use would see paybacks of about 6 years. And with a payback of about 6 years, we estimate that we can achieve a market penetration of between 20 and 25%, even among those detached single-family homeowners. Now, the multifamily market, it makes a lot more sense because this incremental cost is 0. If we can show developers that they're saving money by electrifying their buildings, they're all going to want to go for this. It's just that lack of knowledge that prevents them from implementing.
Okay.
Hi, this is Morgan. Thanks for presenting, Michael. I'm excited to see how much research you put into this so far. I guess my main question is, it seems like there are a lot of different areas that you're starting off with. Is there, if you were to pick one market that you feel like you could make the greatest impact with, where would you start in order to gain biggest product market fit and actually getting into the market?
I think we would start with the multifamily markets because we have a strong relationship with Give Development. They have case studies that are publicly available. If you go to Pragmatist for Clean Air, you can find their full construction sets for an identical building that they bid and spec'd through their professional firms that shows that their multifamily building was less expensive. We know that developers are motivated by initial costs and by getting their investment back as quickly as they can. So we feel like it makes the most sense to start with multifamily because that's where most of the building is going, and it makes the most financial sense right now.
Got it. Thank you.
Hi, this is Mike Pomfret. Great presentation. I guess my my main question is, have you looked at other markets besides the Salt Lake City area and considered how this might be applied across different geographies?
The market that we're most familiar with is Salt Lake City. Markets that would make an equal amount of sense include Denver, Chicago, and some of the other larger metropolitan areas within ASHRAE climate zones 5 and 6. Those are where the climate is cold and where heat pumps are not very strong yet. So we do fully believe that our consulting service can expand to some of those other colder climate cities. Just off the top of my head, Boise and all of Colorado and a lot of Illinois and anything in ASHRAE climate zone 5 or 6.
Gotcha. Okay, thank you.
Final questions from the judges?
One quick question. It sounds like you haven't spent as much time looking into other areas, but have you just taken a quick glance to see if there are any developers that cover multiple cities that you just mentioned instead of just Salt Lake?
We know that there are multifamily development almost always has region spanning connections. So we would work through our existing connections with Give to locate those other developers and see where they're currently constructing and where they're building, and maybe follow the chain of crumbs back to where they're already active. If we engage with them here and we follow them to their other markets, that might be the best avenue for us to expand.
Very good. I saw Ryan pull off mute. Ryan, did you want to ask one last question?
No, I'm good. Thanks, Eric.
All right. Very good. I think that has us at time. So once again, well done. Right now we have Geothermal.
Efficiency is a word emphasized throughout the economic and industrial sectors. Currently, our global power is driven by crude oil, but crude oil can't even be used without first being refined or distilled. Welcome to the higher efficiency distillation solution, Geothermal. Myself and my colleagues have 16 years of combined experience in the field, backing us as we launch this venture. So what is Geothermal? Geothermal is a company ready to revolutionize the industry as a whole. We will provide free implementation of our distillation units, and the energy cost reduction will be the profits for both parties. What is distillation? Distillation is the separation of liquid mixtures by controlled increase in temperature. It is super energy intensive. In the US alone, it accounts for 7% of our energy use. By day, this is 3 million barrels of crude oil. We can't focus on distillation as a whole, so we're going to dominate the ethanol market to begin. Ethanol is used in everyday products such as fuels, pharmaceuticals, and most recently relevant due to COVID-19, hand sanitizer. So what's the necessity for change? We provide a 20% decrease in energy costs for every distillation process. There's also been a global push for sustainability in manufacturing. Let's put distillation at the forefront. This provides saving for our partners and resources for our children. Why ethanol, you may be asking? Ethanol can be produced rather than mined, unlike crude oil. Ethanol also provides a more efficient combustion. This will create a larger ethanol market, which in turn means creating more jobs.
There are also technical reasons to focus on the ethanol production, and we can highlight them by looking at the traditional distillation of water and oil. Heating the mixture, water will turn into vapor or the light phase, and oil can stay as a liquid or the heavy phase. The situation is different for ethanol and water because they are as light or as heavy. So heating the mixture will keeping them as in equal proportions in both phases. In other words, there is no change when boiling, or they form an azeotrope in Greek. As Victor highlighted, ethanol can be used as a fuel, and that's why we need to separate water from the mixture completely. So if we looked at the current production process of ethanol, corn is fermented and water and ethanol mixture is formed through the fermentation process. And to separate water from the ethanol, it's a complicated two-stage distillation process. And that's how azeotrope changes the game, by reducing the two-step distillation process in one single stage by using our nanomaterial technology, saving up to 30% of the energy used in distillation. The fuel ethanol market in the US is huge, and the amount it produces is estimated to be 17 billion gallons. And people in the market are using traditional distillation or rising technologies such as azeotrope and CPure. Our deal to the market is simple. We will give them our units, and for a fraction of the energy reduction cost, we will make our revenue. This is estimated to be $40,000 US per month for every unit sold.
So what about our market strategy? With a competitive advantage of being greener and more efficient, we intend to monopolize the ethanol production market segment in the US. According to Statista and Grand Research, this market is assessed to be $35 billion US. We will use this market to penetrate a larger market segment, which is the ethanol production market segment worldwide. In the future, we also intend to penetrate other markets in the chemical industry, such as crude oil distillation and water desalination. If we had a look on our climate impact, azeotrope is reducing carbon dioxide emissions by 50,000 metric tons per year. So think about it. We take a two-step distillation product, make it one step, and reduce the energy consumption by 30%. This is where the climate impact comes in. So what defines our success? After all, we're a business, and what defines our success is financial stability. Azeotrope needs $3 million US to reach stable and sustainable production of its units. We expect a company value of 6-fold after 7 years of operation. And according to our financial study and units being sold, we expect a payback period of 4 years and a company value of $18 million US after 7 years of operation. This number will be increasing exponentially in the years to come.
So what have we already done? We've already won a pitch competition here at the University of Utah. We've also been featured on a prestigious publication of Innovation at the U 2021. We're also in the process of drafting our patent applications with the center here at the U. So take your stake with us today, and let's save the planet one drop at a time. Azeotrope.
All right, fantastic. Well done. We've got 5 minutes from the judges, and my apologies. I was informed we had an additional, a 6th judge. Haley Reed is joining us as well, so you might have some questions from her. So judges, fire away.
I've got a question about, I'm still trying to analyze everything I just heard, but this is a new way to produce ethanol, a distillation process, correct?
Currently, distillation of ethanol is a two-step process that involves a third component. And with our new technology, we'll be able to distill it in one single process.
Okay, so, and nobody else can do this currently?
No, so our idea is regarding the distillation, which is a separation of ethanol from water. And as Mahmoud mentioned, our competitors here is that our next best alternative is a normal distillation procedure. Okay,
and that process costs how much? And you said something about 40,000 or 400. So I'm just trying to figure out exactly what's going on.
Yeah, it's too much in 5 minutes.
Yeah, in 5 minutes it's hard to communicate it.
Yeah.
So the current distillation process, as I said, it's a two-step, because separating water from ethanol is very hard. It's a complicated process because they form the azeotrope that we talked about. So they do the distillation process over 2 stages, 2 separate distillation steps. Okay, by introducing a third component, which is benzene in this case. This is the accepted way to separate ethanol from water in the current industry.
Right.
So based on our PhD research, we can reduce this in one distillation column by using our nanomaterial technology. So we introduce nanomaterial and we can do it in one stage instead of 2 stages. And that's how we make it more efficient.
So that sounds really cool. So my question is relative to the market. Have you spoken with the market people? And what research do you guys have, if any, where you've talked to 12 people in the industry that go, oh, I'm so sick of the 3-step process. Can't wait for your 1-step process. And if so, what did they say to you?
So in the industry, I mean, because we are still on the lab scale, and actually we need some money to make a pilot plant scale. This is so we cannot we can give them the idea and they will welcome the idea, but without moving from the lab scale into the pilot scale, it would be hard to convince them to try this. But I mean, they will of course accept it if we are introducing a 30% reduction. This is our lab experiments are showing the
Gotcha.
pilot plant with okay.
So I guess sorry, go ahead.
Sorry, Michael. Hey, this is Ryan Charles with US Bank. Just had a quick question, not totally understanding this, not a science guy. So you're using nanoparticles to separate it out? Is that what's going on here?
We're using nanopores, mesoporous materials.
Okay, and what's the availability? Me not knowing, just help me understand what's the availability of that material and what, as far as scarcity of resources, where are we at?
Yeah, so according to our PhD research, this is also something that we manufacture. So the material itself is not available at this point. This is one of the things that we are documenting the pattern right now with the university. So the material itself, we will be manufacturing it. This is even including the financial model we did, like the cost of manufacturing this material and maintaining it.
So the material is made from silica. It's not expensive, but there is a way to make the material. That's why it's unique. But it's made from silica and simple materials, I would say.
Perfect. That's what I was looking. Thank you.
Out of curiosity, can this same distillation process that you've discovered work for other types of products that might be alternatives to ethanol?
Yeah, it works. It works for multiple distillation processes, but we will focus on the ethanol because it's more efficient due to the azeotrope formation. But we can transfer this to water desalination or even crude oil. But ethanol is more efficient due to the azeotrope we talked about. It's transferable, I would say.
And this is also, if I can add to this, why we determined for the ethanol production market to be our beachhead market we start with, because there's other possible markets that we can also penetrate. But it was more based on demand, basically.
Got it. Thank you.
When you talk about pilot plant, what size are we talking about? And how much ethanol is going to be produced? How much is one of these plants going to cost? And is the plant the same thing that you referenced when you said $40,000 return per unit?
No, the unit for the pilot plant would be smaller than this one, but it would be a great proof of concept on an industrial scale, because the distillation unit for ethanol is larger than this. So the one we built, it will cost more, about 20K in this range, just to prove the concept. Like the science we discovered in the lab can be transformed into a larger scale by manufacturing like larger material, nanomaterial, and applying some controls and some technical to the pilot plant that we can transfer easier to the industry.
Okay, then just maybe just a quick question about a hard number. How much ethanol are you looking to produce in the pilot plant?
So in regards of this $40,000 US per unit sold, if I can go back real quick to this slide. So here what we mean is that our cash flow model is based on the utility cost reductions that our customers are going to save. So let's say in one case, random case, when applying our unit in their process, they will save like $100,000 per month on utility. So this is a fraction of the energy cost reduction we take as our payment. This is also one thing we thought of to prove our credibility of our model, because we will only gain revenue from when they save. So because we are very sure that they will save, and this is how we make our revenue from them. So if we are switching our business model a little bit, thinking of making our own pilot plant to produce ethanol, this is something of course we can study and know how much we can produce. But in this business model, we are not the ones producing ethanol. We are selling our units to already established ethanol producing companies.
All right, and that is all the time we've got for questions. Well done, Azeotrope. Okay, so to Ted's point last time, we are going to squeeze in a 1 minute time frame for judges to put their notes down on their sheets. And while we do that, we're going to have a few things to accomplish. In this particular 1 minute, the first thing that I'd like to accomplish is we got to get a picture of everybody, because it's 2 years into, almost 3 years into Zoom meetings, and we're still doing this. And we've learned that when we get pictures of everybody, just randomly snapping one or doing a screenshot doesn't work. So what I'll ask is, if you're comfortable, flip those cameras on. It's like having power. It's really, when I can go like this and things happen on my screen. I love it. Okay, Casey's going to be ready with the good old camera trigger figure, and we're going to count to 3. You can give me a big smile. You can make a funny face. You can do whatever. Yes, yes. Peace signs on the count of 3. Ready? 1, 2, 3. I like it. Very nice. Okay, and while those judges are taking, and you are more than welcome to remain on camera or flip back off, whatever keeps you comfortable. I'm just blown away. I think this is the first time in 3 years of doing this where I've asked people to do that, and everybody was like ready to go with their cameras on, looking good. Impressive. All right, so that said, final thing to take care of during this quick 1 minute judging deliberation time is a dad joke, because now that I've threatened you enough with it, I am going to go ahead and do those. All right, so the dad joke for this 1 minute is, my wife said I should do lunges to stay in shape. That would be a big step forward. I just can assume
I
that
like
you're all
it.
on mute and you're all laughing. Okay,
I like it.
very good. So moving right
Where
along.
do crows go to have fun?
Where do crows go to have fun?
Where?
A crowbar.
That's pretty funny too. Feel free to input your dad jokes in the chat as we go forward. Brian, nice one. I like it. All right, coming up right now, we've got Hawaii Innovations, and on deck is Nathan Wolf's team. Hawaii Innovations, are you ready to go?
Aloha and hello everyone. We are Hawaii Innovation Lab, here to talk with you about Water for All, a deployable solar thermal desalination system. Earth's surface is 71% water, and despite this fact, lack of water is becoming an increasingly predominant global issue. According to a UN statistic, approximately 850,000 people die annually from dehydration. To add insult to injury, the majority of these deaths come from the 84 million people who are forcibly displaced, also known as refugees. While many of these refugees live in refugee camps, the sad reality is that the majority of camps cannot actually afford standard water production systems that are capable of handling their water needs. We propose a system that will generate water for these refugees, all while being affordable and feasible for camp administration. This system is deployable, allowing for a quick and easy setup wherever it's needed. This system also has a low price point and low maintenance costs, meaning that water production is within reach for refugees. And now, introducing Water for All.
Our product is a parabolic trough solar thermal desalination system, where the water evaporation takes place inside a uniquely designed receiver tube, and the vapor is condensed by passing it through saline water reservoir, generating potable water. The design allows passive heat recovery from the vapor and brine without using any heat exchanger. A 5-trough plant is designed to produce at least 1,000 liter potable water a day at 25 liter per square meter of reflective surface for solar irradiance of 4.8 kilowatt hour per square meter a day. The specific water productivity of the system is 5.2 liter per square meter per hour, which is 40% higher than the average specific water production of conventional thermal desalination systems such as MED and MSF.
Our customer segments are coastal refugee camps and humanitarian organizations. We've actually interviewed over 50% potential customers, and many of them have expressed interest in using our product. including the Rohingya refugee camp, whose manager expressed interest in not only a partnership, but also in providing land for the pilot project. The total available market for solar desalination is $1.84 billion, with a 36.6% share of solar thermal systems. Our serviceable available market is approximately $736 million. Our estimated serviceable obtainable market is $36.8 million per year, which is 5% of our SAM. Unlike most of our competition, our system has no recurring costs. It's entirely off-grid, and it's easily deployable, being able to be set up within a day. Competitors in this industry compete on the fronts of production and price. And as to be expected, high-cost systems produce large volumes of water, and low-cost systems produce low amounts of water. The gap in the market is right here. There are no low-cost systems that are also high producers. And this gap in the market is exactly where Water for All is positioned, costing as little as $3,600 to consumers and producing 1,000 liters of water per day. Our profit margin per unit will come out to $1,200. And if you'd like to know more about this number, I would be more than happy to talk with you about it. Our revenue model is sales in North America and Europe and licensing in Asia and Africa. We plan to charge 20% royalty, generating an annual licensing revenue of $30 million. Our estimated annual income from sales are $6.8 million. And in the first 10 years of commercialization, we estimate to capture the serviceable available obtainable market of $36.8 million. In order to achieve this ambitious goal, we've assembled a qualified team consisting of myself, Brandon, a senior business student at the University of Hawaii and chief business officer of Water for All. Mohammed is our senior scientist and a PhD student. Kareem is our chief technology officer and is currently a student pursuing a BS in engineering. We're all very blessed to live in a beautiful country like America, and this gratitude turned into a drive to improve the lives of the less fortunate. Even as we speak, it pains me to think about just how many people are struggling to find enough water to survive. And rather than just sit here and feel bad, we decided to actually take action, and this is why we created Water for All. We plan to complete our R&D in 2022 and carry out the pilot test in 2023 at Keahole CSP site at Natural Laboratory Hawaii Authority in Kona. Also, we plan to secure a pilot sale to Rohingya refugee camp in 2024. And if successful, we expect to secure an order for 104 additional units to that location. We will begin mass production in 2025, and if we can raise the investment mentioned in the slide. Thank you all very much, and we ask that you join us in our effort to provide water for all.
Okay, Hawaii Innovation Lab, great job. 5 minutes for question and answer from the judges.
Question for setup. How long on average does it take to set up the actual product in the field? And are there any materials that you need in order to actually set it up properly?
That's a great question. So the system can be set up within 1 day and actually starts producing water within the same day that you set it up. All the materials that are needed will actually come with the product. So there's no external materials that you'll need to buy or need to purchase from anybody else. So once we deliver the product to our consumer, they can set it up. They don't have to buy anything else, and they're good to go within that same day.
Very helpful. Mm-hmm.
Can you tell me, relative to something that we might all know, like what's the size of this thing? It's its physical size. So the size of like a single bed, you know? And
I'd say it would be about the size of maybe like a king size bed in length and height. Well, height, I mean, you know, the length of the king size bed.
Right. Okay. All right. And then, so it's clear who your users are. It seems like these are individuals in developing countries. That's kind of, but no, so your customer is who's, because I would imagine who's buying the product. I know who's going to be using it, who's going to be the benefit, but who are your actual customers that are transacting the 3,600 with you? Because I don't suspect that some of the refugees probably don't have $3,600.
Yeah, absolutely not. Refugees, they don't have a lot of money, unfortunately. So our consumers are the camp administrators who also, they don't have a lot of money to spare for these more expensive systems. And so our system, which is priced competitively at $3,600, which is much lower than other systems that produce almost less water than our system. And so the camp administrators would be the one who are purchasing the systems using the funds that they have.
Okay. Go ahead.
Oh.
No.
Hey, Brandon, sorry, just a quick question. This is Ryan. Not totally understanding, but your saltwater process there's going to be some junk that's taken out of that water. Is that right? And where does that go? And so what maintenance is this going to need on an ongoing basis?
Yeah, so the junk that's going to be taken out of the water, if I'm just going to flip forward a few more slides. So what's going to be taken out of the system is primarily salt and these types of debris. And while we're still working on a solution for how to dispose of that in a responsible way, that is something that we have at the forefront of our minds. We're trying to develop a solution for this. You also asked about.
So
I'm
can
sorry,
I add,
what was the second part of your question?
Brandon?
Yeah, go for it.
Yeah. So so right now our plan is to dispose this brine, rice, and wastewater to go back to the sea. So it will not any adverse effect to the environment. So the disposal will be, I mean, there will be outlet connected to the sea that will go back to sea.
And that process though is automated, or do you expect your users to be out there cleaning the system and doing that?
So the connection, we plan to set it up with gravity, so without using any external power. So it will go back to sea by gravity.
Thank you.
Yep.
Can the user tell if it is not actually working?
I'd say one of the biggest indicators would probably be the amount of water it produces. That would be probably the biggest giveaway for whether or not the system is working to full capacity or if it needs a little tweaking done to it. If that answers your question.
So if I add with Brandon, so the system is dependent on the solar irradiance, you know. So solar irradiance will produce vapor, and vapor condensed, and fresh water is produced. So there is no way to, I mean, stop production of water unless there is less solar irradiance. So of course, yes, user can identify their problem, and it's actually a very simple modular design. So in case of any failure of any module, it can be replaced and repaired rapidly. So we can also provide extra modules to the consumers.
All right, and that's all the time we have for Q&A. Well done, Hawaii Innovation Lab, and we're going to give 1 minute for the judges to write their notes, and I will give you another dad joke. And I like this one. This one's real bad. So what do you call a factory that makes okay products? A satisfactory. Huh? All right. All right. Well, I saw the Hawaii Innovation Lab guys laughing. That's got to count for something, right, judges? So okay. Very good.
All righty. Welcome and thank you so much for having us. We are Revolut Robotics, and we make inspection robots for inaccessible places. Robots have many disadvantages, from speed, accuracy, and mass data collection. But what you may not know is that robots have flaws too, specifically in the indoor environment. If you've ever flown a drone, I'm sure you can relate to getting 15 minutes into your flight before the controller starts beeping at you asking for a battery swap, thus significantly decreasing the distance of each mission. This has happened to me personally many times when I'm trying to take video and can't, fully complete what I'm trying to do. What's more is that they are extremely difficult and dangerous to fly indoors and typically require a skilled operator with a stack of certifications larger than a phone book to do so successfully. Rovers, on the other hand, present considerable improvements to operating time and ease of use, but this comes with its own set of drawbacks. Their large size and low mobility means that any obstacles or uneven terrain greatly limit the robot's areas of application. Our solution is to offset those robots' limitations by combining their capabilities.
Our robot's spherical design and ability to both roll and fly will allow it to safely operate in confined spaces to collect data where other robots cannot travel. The ability to roll gives it an operating time of up to 10 times that of a typical drone, which significantly increases the distance and duration of each mission. Our robot will also feature fully autonomous operation to eliminate the need for human interaction. And you might be wondering how it's done. Simply put, our robot is comprised of a multi-rotor mounted in our patented stabilizing unit inside of a protective shell. It can be equipped with any mix of cameras and sensors to collect mission-specific data for different industries.
Although many industries can benefit from this product, the most immediate demand lies within the energy sector, with up to 30% of a building's energy expenses being wasted on air leaks alone. It's estimated that around $2.9 billion are lost every year due to duct leakage. Our robot is the perfect solution to solve these challenges. Because our robot can switch between rolling to save energy and flying to travel vertically, it can navigate places that are off limits to any existing solution. Equipped with a thermal camera, it can identify air leaks and other anomalies that waste energy and contribute to harmful greenhouse gas emissions. Not only can it detect leaks that are otherwise undetectable, it can also repair them by using a sealant spraying mechanism. Here's a short video to illustrate how it would maneuver through an air vent. Oh, sorry. Our robot allows us to detect leakage much more effectively than any existing solution. Repairmen with thermal cameras have to scan room by room. Retractable cameras, also known as snakes, that can be pushed through the vents, have very limited reach. And then rovers can only travel one floor at a time, provided there are no gaps in the floor. But our robot is able to scan multiple floors at a time fully autonomously. And this might have you thinking, this is too good to be true. And you might ask yourself, what about the propellers? Wouldn't that affect the thermal imaging? Luckily, since our robot is flying and rolling, we can simply just turn off the motors while scanning for those leaks. The market we've identified is a large one, valued at over $15 billion and at a growing rate of 6% each year. Our customers are the inspection companies like ESCOs and HVAC repair companies that are contracted by large buildings to help save money on energy usage and fixed duct leaks. We are currently in the process of setting up a demo with a local HVAC company to get a reliable review. Our team is composed of 2 students at the University of Arizona. It's led by Nathan Wolf and myself, Harry Chu. And we're also backed by an aerospace PhD and former NASA engineer, along with a former drone company owner operator. We're also fortunate enough to receive support from the advisors you see on the screen. With that, I'd like to thank you all for your time and open the floor to any questions.
Okay, well done, Revolut Robotics. Let's go with some questions from the judges. 5 minutes.
Can you just, I'm a little confused on where the technology is in development. Is this something that's that you guys have a prototype of? Can you give a little more context there?
Yes, we currently have a working prototype. Due to timing in the presentation, we did have a small video of it working. So just like you saw in the duct there, we are able to take off, roll around, and have some different configurations with the inside stabilizing unit.
So is this IP, like, is there a patent, or like what's the?
Our internal gimbal with the stabilizing unit is patented at the moment.
Perhaps I missed it, but what would one of these systems cost, or what's your ultimate price point?
Yeah, so the cost of production is around $2,900, and the sale price we would be going for is $4,800 with a data subscription to go $1 per mile autonomously through the ducts, and with the service warranty of $300 per year. You can buy it all outright, a direct sale, one-time production cost, or you can kind of do a lower upfront and shorter sales cycle and make payments. All with a monthly data subscription and service warranty.
And how does
So
that
it can-
compare to current options like the snakes and so on?
Our solution is the only autonomous one, so you wouldn't need a repairman to come and actually inspect the ducts, and they usually charge around $75 to $150 per hour, depending on the company. With our robot being autonomous, it can go through the ducts by itself, and it'll have a sealant spraying mechanism to patch the leaks.
Okay,
You
thanks.
wouldn't have to have somebody control it, like you'd still need wouldn't you need somebody? Or is it completely autonomous, like there's no human intervention?
So that it will be controllable just by its own joysticks, like standard controller. The autonomy would be once it gets into the air duct, then it will be able to navigate and avoid any obstacles. So some initial supervision would be needed.
Got it. And is that built into your model, the pricing model?
Yes.
Okay, thank you so much, Revolut. We're going to allow for 1 minute for the judges to deliberate. We have Binod's team, who's going to be right up next. On deck, Arctic Biotech Oath.
All right, perfect. Can you hear me, correct? Yes, all right. Thank you very much. My name is Michael Martinez. I'm a senior chemistry major here at the University of Alaska, Anchorage, representing Arctic Biotech Oath, ABO sustainable rare earth elements. So what are these rare earth elements exactly? These are the elements highlighted in orange here on the periodic table, and these are able to produce strong magnetic permanent magnets able to be applied in aerospace, renewable energy systems, and electric vehicles. It's estimated to be worth about $32.86 billion by 2027. And essentially, whoever controls these rare earth elements is able to control the movement of energy and new technologies. So conventional methods here, especially done by current mines, as well as some other rare earth element projects such as Mountain Pass, Brain Extractor, and Medallion Resources up in Canada. A lot of these use acid leaching conditions, which exactly may cause acid mine drainage, such as being seen in the Colorado River watershed. If we keep seeing these different methods being applied and these spills happening concurrently, we're going to be taking out the freshwater sources of the United States continent. So what are we proposing exactly is biomining and bioweathering that operates at pH 5 to 8, so circumneutral pH, targeted for the yet to be established 7 rare earth element deposits right here in Alaska in the Arctic. So if we're able to see here, you guys can see in my left-hand corner, our technology actually works. The bacteria actually grow, proliferate, and extract from these different mineral feedstocks and the rare earth elements. And what separates acid leaching done by conventional companies and bioweathering, acid leaching occurs in set pH acidic conditions, whereas bioweathering allows for the bacteria to grow exponentially and multiply, and they are also living. So they need these minerals to survive even in harsh conditions. So if we're able to draw and actually see this compared against one another, we're actually able to see that bioweathering outperforms and is superior to acid leaching methods here. We plan to integrate this into a $3 billion headquarter facility here in Alaska, about 500,000 square meters, to extract, refine, manufacture, and recycle these rare earth elements, especially with the help of other DOE patents and scientists, such as from Bave, Schneider, McIntyre, and our technology being the focus of the biomining extraction method, which takes ores, tailings, wastewater, and use rare earth elements to actually make the final rare earth element magnet products for United States technology industry partners. The goal here is to make 3,000 jobs available for Alaskans here in the United States, as well as be able to integrate robotics and automation to make sure that this is operating 365 days out of the year. So what are we looking at exactly? To give an example, with the new White House announcement, the Buy Back Clean Task Force is going to be actually looking to buy and purchase American-made products. And where will these go to? For example, if we're looking at the electric vehicle market by 2030, that's going to be worth about 823 billion. And looking at the aerospace industry by 2030, about $1.25 trillion. And here, being on a base to contact one-on-one collaborations with, hopefully in the future, these US technology partners, we will be able to make sure that their magnets are up to grade, they don't degrade in their actual devices, and that these products are made sustainably. So to compare our profit margins, what we will be making to a current rare earth element project, if you look at Linus, for example, in fiscal year 2021, they made 157 million, but I think we will make more. So if we're going to be looking at our costs in 2022, so about this year, being able to take into consideration operations, labor, systems, and upgrades, but transfer that to finally in 2030, where we actually finally make profit at about 175 million. If we move that trajectory to 2040, with operation costs being about 30 million, we will have made 1,305 million. But because these new industry markets are growing, especially here in the Arctic and with the new ports opening, we can triple that and see, for example, by 2040, 4,455 million can be made. So our current team right now is comprised of myself, Michael Martinez, Dr. Brandon Briggs, our Chief Technology Officer, as well as Roger Gebauer and Brooke Branson here at the University of Alaska Anchorage. Right now we have collaborations from 7 mines and 9 sites, and are also increasing our feedstock operations and gathering those to be able to test and modify our samples too. And finally, we're trying to scale up, get efficiency to actual bioreactors so that we can implement this, and finally develop actual US and government partners to see this through. So thank you very much for listening. Arctic Biotech Oath, we are a green metals and solutions company.
Fantastic. Thank you, Arctic Biotech Oath. 5 minutes on the clock for Q&A from the judges.
All right, perfect.
Hi, Michael. Hey, this is Ryan with US Bank.
Hey, Ryan, how you doing?
Hi, good. Hey, can you help me understand? I'm sorry if I missed it. That 5 minutes goes quick.
Yeah.
You want to displace that traditional method, but what is the efficiency of this bacteria compared to what we've got now, and how likely are folks to adopt what you're proposing?
That's a great question. So we're able to actually extract about 70% of the total rare earth element concentrate from these different ores. And right now, I think with the current global situation is kind of showing that these different minerals and also the use of fossil fuels, there's actually quite a bit of coal companies within the US that are looking to transition the use of their coal. And one of our primary feedstocks that we've been able to extract from is actually coal, along with other feedstocks such as clay, tailings, and we're moving into hard rocks right now. But coal would actually be one of the main ones that we're able to extract pretty well from actually right now.
Okay, thank you.
Yep.
Additional questions from the judges?
How does the price of your process compare to what's currently out there? I mean, granted, you know, a lot of the rare earths mining happens overseas, so that's a consideration. But just trying to get a gauge of, you know, more of the benefits on that cost side of what you're trying to do versus what's currently available.
Yeah, that's a great question. So I think especially trying to get exact pinpoint costs, trying to get those up, a lot of those are actually maintaining control by different governments, whether it be from China, different from Indonesia or Australia, or also even here too, it's hard to gather those prices. But I can actually say some of our methods in a laboratory setting actually, perhaps considering analysis cost, the ore and shipping to actually get it over here, the hands-on labor of either myself as a technician, Dr. Briggs, or our other assistants or other labs also, you're looking around about $12,000 to $15,000 to actually get that going. But if I can say also, this is not only looking at one bacteria, it's actually the process of making a catalog so that we're actually able to see that these different deposits, we're actually able to integrate our technology with and make sure right now that it works with those actual deposits, because those different deposits is different for each region, whether it be here, Canada, or even from China. They have different rare earth element deposits from up here in Alaska. So it kind of depends. It kind of depends. And I think with the new White House announcement being that bypass clean the Buy Back Clean Task Force. I think one of the main calls is to see that, is there a place of negotiation between these new startups to see if there's a price point that we can actually agree to.
Final questions? We have a little bit of time. If you have one, please feel free. Okay, fantastic. Thank you so much, Arctic Biotech Oath.
Thank you.
And we're going to put 1 minute on the clock here for the judges to get their notes down. We have Ultropia, who we will have coming up right now. I saw Cody there earlier on deck.
Hi, I'm Cody, engineering master's student at the University of Washington, studying ultrasound at APL Center for Industrial and Medical Ultrasound. My teammate Lloyd is a master's student at the Foster School of Business, studying technology commercialization. With our team, Ultropia, our mission is to foster global accessibility to sustainable laundry by using ultrasound technology to make laundry appliances significantly more efficient. There are 5 billion people who still wash clothes by hand. The US is one of a handful of countries where washers and dryers are standard issue. Even die-hard environmentalists don't give up their machines. The problem is our current appliances. They're resource hungry and highly polluting. US washers and dryers produce 179 million metric tons of CO2 annually. That would take half the trees in the US to keep up with. We've spoken with people all around the world about their laundry needs. Extreme poverty and a lack of infrastructure are huge barriers for many, but surprisingly, even developed countries have limited access to washing machines. Our team's business lead, Lloyd, has family in Fiji that need an entire day for the labor-intensive task of doing the family's laundry. Christy, a local preschool teacher who grew up in Nicaragua, visited home to see that her family had bought a washing machine, but rarely used it due to energy costs. My mentor, Dr. Nathi, comes from South Africa, where water scarcity prevented machines from being practical. The average load takes 19 gallons of drinking water. Even Greg, our business mentor, who's a successful entrepreneur himself, had trouble finding condos that could support the infrastructure requirements of traditional washers and dryers. Connecting with many people like these, we resonated with their stories. Networking has been a critical part of building this business. We wanted to learn more about our potential customers' pain points, as well as educate ourselves to make sure that we're addressing the problem to create the best solutions. We made sure to seek out mentors in any area we were weak in, from customer discovery to product manufacturing, as well as marketing. People were excited to help students on campus become a catalyst for change. Our solution uses ultrasound technology to wash as well as dry clothes. Cleaning works by using ultrasound to drive the creation of vacuum bubbles that, upon collapse, gently expel dirt out of clothing. The drying process uses ultrasound to atomize water droplets, reducing the heat required. We're taking learning from the ultrasound lab and combining it with ultrasound drying research developed at Oak Ridge National Labs to create the world's first ultrasonic washer and dryer. We've translated this research into a tabletop version that uses our technology to wash and dry small items. The technology has diverse applications, and commercialization of smaller versions will support our long-term development. We've compared our ultrasonic cleaning to conventional washing machines. As you can see, the results are fairly similar. The real difference is in the resources used. Our bench tests for washing show faster cleaning, less water use, and significantly less total energy compared to a modern mid-market washing machine. For drying, we're building on research from the Department of Energy and Oak Ridge National Labs, which shows drying in 7.5 minutes with 5 times efficiency gains over forced air dryers. This technology uses fewer moving parts, enabling our design to last longer. It also allows us to create a compact, all-in-one unit that will be more affordable to manufacture and ship. High efficiency allows us to offer a configurable water supply and compatibility with a standard wall outlet to foster accessibility for resource-scarce communities. We're challenging GE and Samsung with our all-in-one product that is 1/3 of the size and moves beyond the expensive, damaging rotary drum. Other ultrasonic cleaners are on the market, but our product is unique, using ultrasound to wash as well as dry clothing, saving water, energy, and time. We're opening up new markets, starting with providing access for the millions of Americans who do not have in-home laundry. Globally, the market is big, $66 billion, growing by 34% over 5 years. We're pushing to get to market in time to meet this surge in demand and prevent the resulting increase in pollution. Hardware has high initial costs, but laundry is a universal problem. Our plan is to start in the luxury market with high-end consumers who care about their eco footprint and need a compact laundry system for their urban lifestyle. Our research shows that these consumers would be willing to pay $1,500 a unit to address their needs. From there, we can scale our manufacturing to reduce product cost to around $500, allowing us to sustainably meet the growing global demand for washers and dryers. We will work with the Alaska Native Tribal Health Consortium to get user feedback, as they have expressed a need for a resource-efficient washer and dryer. We're developing our product at our university's CoMotion Labs, which has the resources to connect us with people to manufacture our product. After gathering user feedback and establishing manufacturing connections, we will launch our product through a crowdfunding campaign. Commercializing this technology can change so many lives. Laundry appliances are considered essential infrastructure in the developed world, but the current processes are simply not sustainable. Changing the way we do laundry will make hygiene a part of the energy transition and enable a global standard of living we all want to share.
All right. Ultropia, well done. Congratulations. Let's go 5 minutes for judges Q&A.
So with regard to who your target customer is it individuals or households that currently have in-home washers and or dryers that you'd be replacing them with this something new that's more economical, or are you trying to open up markets where laundry's been inaccessible because of costs?
Well, it's a little of both. Our challenge is scaling the product and the manufacturing to meet the existing demands. Competing with these massive manufacturers is tough, and that's why we're going for the more underprivileged markets that just don't have access to these things due to remote living areas, high energy costs, small living spaces. And so seeking that as kind of our entry level, like kind of beachhead market, just because that's where a lot of the need is. That's where there's not a lot of competition, and we're really offering a solution that fits with them. And that market exists across all income levels. There's high income people in condos or mobile homes, RVs, things like that. But we also are really interested in helping not just individual consumers, but also organizations, local native tribes. That the resource sovereignty and the cost of resources is a really big pain point for them.
And would your this technology be similar? I mean, it's an actual physically smaller unit.
Yeah.
Especially
since it's both in one unit.
To wash and dry?
Yes.
Okay, so it's just one, and would the unit be about the size of either a washer or a dryer nowadays?
Yeah, we're starting with one that's more compact because that's where the really strong customer need has been expressed, and we know that there's a really big and strong customer need there. And so starting as that would be our beachhead market. It's a smaller unit, but then we'd scale the technology up to be able to compete with these high capacity washers and dryers that are on the market now.
Okay.
Yeah.
Final questions from the judges?
I just have one other question. Have you made, I saw you had some stuff from the lab and you showed like some kind of fabric where you tried it. I mean, have you done anything? Do you have a working prototype that's the size or scope of what you'd be selling to the marketplace, or is?
Yeah, so right now we're really focused on optimization as well as really nailing down the technology that we're seeking to patent. But our test chamber can hold maybe 2 cubic feet. So that's pretty decent, but the smaller scale product that we're kind of using is like a benchtop demonstrator. That's mostly for kind of characterizing the process.
And so like in this process, pardon my ignorance, do you add any soap or anything like this?
Surfactants help a lot. The ultrasound has the advantage of not just relying on just the material being dissolved in water. There's actually a mechanical action that's happening there to dislodge things. but it definitely helps with oil-based stains. For pigments and things like that, ultrasound is very effective.
But does it create that? I mean, are you supposed to put soap in to create like its scent or something like that? Because part of the cleaning process is the illusion of it. Oh, it smells clean.
Yeah, so I think that's a big thing. They'll just take customer discovery. There's a lot of things we could do with ultrasound to make proprietary detergents, but I think there would be a lot of interest coming from the consumer needs to sell them, or to be able to work with their existing detergents, or preferably more environmentally sustainable detergents.
Okay. We probably have time for one more.
Yeah.
One more question. No? Okay, that's okay. Well done. Thank you, Cody and Ultropia.
Yeah, thanks so much.
Hello, everyone. My name is Paul Tice, and I'm presenting from the University of New Mexico. And we are presenting the Generation Grid Business Plan by PSU. All right. Why should you choose us? Well, we're a good fit for portable market power. We can use for commercial or not agricultural, but we're good for the commercial market and the average consumer. It's cost effective. We offer low volume and it's high weight. What is our product exactly? The Generation Grid is a green amorphous grid / edge server. I know that's kind of a lot to take in mind, but we want to take the real world in the environment and adapt your technology with your solar panels or any other modular type of energy generation and create them in a combination with an edge server. So what's an edge server? A lot of data goes in and out of the servers for networks, and this data is essentially worth a lot of money. So our concept is that we want to not only mine energy, but we want to mine data. The other applications involve, for instance, high data transfer in particular areas where a lot of people were to join up. So it's adaptable for gatherings, stadiums, and concerts. What is good about what we are doing? It's low power, high speed data transmission. Now let's go back real quick and look at this slide real quick. This right here is a collimation lens using free space optics. What is that? That is a laser essentially. We can offer our package to transfer data in high amounts for low amounts of energy. And this is good because our ultimate goal for the Generation Grid is to connect the unconnected. Half the world right now does not have connections to the internet, and we would like to provide them. Generation Grid is going to do those services. We can rapidly deploy these green core networks. They're modular and expandable. Edge computing and data technologies. It produces its own energy. We currently right now have testing laser transfers in our laboratory, and we can get up to 1 gigabit per second for an Ethernet connection of free space. What does that mean? A laser in space can shoot a file that's 15 gigs from here to there in 15 seconds. And we're working on right now using that over larger distances and having a tunable options. Compared to other things, it's much better. Obviously, in a magnitude of multiple decades. We are aided by multiple professors, Professor Dr. Yorgos Marinakis, Ramiro Jordan, and Shang Sun. They all help us work with our research. We're a collaboration of engineering students and business students. We have masters in a business helping us guide our way to continue to develop our business model. So potential customers, residential customers, first responders, underserved. Ultimately, we would like to be able to set up a drone set, a backpack-sized drone setup to be sent out into a place that has no infrastructure whatsoever, so that maybe the medical community can communicate and the first responders can send imagery at high frequencies and speeds. Try to save lives. There's a need for that, and we're designing this technology right now as you speak in our labs. How are we going to fund all this stuff? Like, really, let's just get down to it. Well, let's talk about the grid. Let's talk about things that are being attached to the grid. Right now, the Internet of Things devices it's only increasing, and the IP addresses we have available need to be expanded. Everything is going to be attached to the grid, so everything's going to need to go through these mobile edge servers. Our cars can be part of these generational grid devices, so can our garden. We can recycle our old cars. All that old steel can be reused. We can take our stuff in our space we have and we can reuse that, and we can offer it to the American consumer so they can also spruce their garden up and also help our cause. And ultimately, our third and our largest revenue getter will be the data itself. Data is the best form of money right now, and we plan on using the future generations of infrastructure to farm this data with our MEC servers. Yeah, basically generation benefits first world responders, because ultimately our goal is to help the underserved. We want to empower those who do not have the option or have the idea of the internet. Sudan, Africa right now, there's a call to justice right now, and we're developing a prototype to help those first responders to transfer data with our laser system. Navajo Nation, hey, we're in New Mexico. That's the state between Arizona and Texas. And right now in our backyard, the Navajo Nation, they could use this help. During COVID, we all got sent home, and some of my fellow classmates had to drive 40 to 50 minutes just to get to Walmart or someplace so they could use the internet. If they had this technology, they would be able to have a high-speed internet connection at the wink of a hat, wink of an eye. Anyway, it's climate aware as well, too. Again, potential impact, first responders, save more lives, high-speed medical imaging. What we offer is high-speed, low data transfers, long distance. You couldn't put this type of data information on GSM or AM/FM radio frequencies that are either regulated or just can't handle the bandwidth. The underserved, farming, we want to be able to bring resources to those that don't have it. If they could build their own grid with improvised batteries, lead acid batteries they had around, maybe they could have internet for longer. And eventually, our ultimate goal is WET, water, energy, and telecom. We think everybody deserves access to that as peace engineers, and that's a concept we want to bring to the world. We want to bring green, sustainable future for everybody. At the same time, we want to give everybody a fair shot at all the information we all take for granted.
All right,
this
Paul,
talks about how.
Paul, your time is up, so how do you just wrap up this this thought here?
Great. Yeah. So this is expandable, and if you think about the future and all the technology devices, cars are going to need to be able to respond faster. Our data grids will provide this augmented reality and cloud computing purposes. Right now, we have two seniors in computer engineering. One is a master's, or both of them are masters. They're identical twins. And we have a master's in business student. We formed a club, Peace Engineering, Technology, and Entrepreneurship. And we have about 12 people who show up on the regular. Thank you very much.
Great. Thank you, Paul. All right. We've got 5 minutes for Q&A from the judges. Go for it.
So I'm trying, as I was trying to put it all together in my mind, and so let me know if I'm missing it here. I just read a news article, I think it was today or yesterday, about Elon Musk just located his Starlink technology, where you got access to the. I mean, are you guys the same? Or is that similar? Am I missing something? Are you guys?
Yes and no. We could pair to a Starlink setup. However, these can be rapidly deployed. Like, let's say our mission is in Sudan, Africa, to bring the EMTs high-speed data transmissions. We can set up a relay on top of the hospital and use a drone in a backpack to get up to 20 kilometers of high-speed data transmission. So not necessarily. It's meant to be more modular. And if we need to set them up on the fly or wherever we need to go, because it also needs to be discreet as well. Some of these countries are emerging and they have no government. Currently, Sudan is in a coup, and we can't just go set out regular technology. It might just get destroyed or taken by the people who live there. So we need to have some sort of discreet kind of packaging, and that's where the plants and the natural landscaping comes in. And this could also be for the consumer, right? They could set their guard up and know that they're doing the right thing. Maybe possibly connect to Starlink in the future, or their own personal grids that we can, core networks we can establish within an area.
Also, as for the internet, this is more of an augment to the internet. A lot of the devices that we use, like the gaming and, for instance, some connections we need to have high-speed data transfers, and those devices won't be able to use that. this data slides on the edge of the network so that it can be passed to the core and back to the edge device very, very rapidly, right? Because as the devices increase, the response time in the data servers is also going to decrease. So we need to, as a whole humanity, need to figure out a way to have our response times increase for the future grids and generations of networks technology that's going to be made. Does that make sense?
Yeah.
We're making them anyway. They're coming.
Hey, Brian and Paul. Yeah, sorry, Eric, Brian and Paul, can I just confirm and make sure this technology, is it line of sight dependent?
Yes.
When you have the picture here with the transceivers?
Yes. Our collimation packages work on line of sight, and they actually work better in the fog than bright light.
Thank you.
So who's the initial customer or beachhead? I mean, you gave a lot of different options for who could buy this or how it could be deployed.
So our initial customer is our emergency medical technicians in Sudan, Africa right now. This is a senior design project that we're piggybacking off of Engineering Without Borders. And then they've tasked us with a mission to provide portable power and high-speed medical transmissions for these EMTs. I'm not sure how much you know about EMTs, and I didn't know this before, but they're not making all the call shots as they're saving lives. They're constantly communicating with doctors. They're sending back images. That they have machines they're running. And right now they're at the frontier medicine, essentially. And so they would be who we are initially contacting. And obviously they don't have, like, the people of Sudan don't have a whole lot of money. So the idea would be to sell some of our products to consumers. Maybe they would like to know that they're helping others around the world, and they could put their products in their yard and design their landscape. So it's kind of a little bit of both, but mainly it's for altruistic reasons why we're designing this technology.
Okay, thanks.
Do you have any final questions?
Hey, Eric, I have one question for you.
Go for it.
Where do crows go to have fun?
The crowbar.
All right. That's what it's like being a twin, Eric.
That's right. And with that, we will turn it over to the judges to get their comments and notes written down. Paul and Brian, will have you guys unshare your screen.
Okay, thank you so much for your time.
Yes, thank you. In the meantime, we have software.
Good afternoon, we are the software team, and today we'll be presenting our smart air particulate matter monitoring software. In today's world, air pollution is a big problem, and the fact that 90% of Americans spend 90% of their time indoors in their homes, we want to be able to address this problem, how to effectively keep air quality management inside a building. With this in mind, with current global problems like wildfires and the COVID pandemic, about $1 trillion per month globally were wasted on poor air ventilation. And this also decreased the productivity of people, and it costs up to billions and trillions of dollars for the United States. To be a little bit more specific, building engineers have certain pain points of figuring out when to let outside air in and when to recycle the air inside of the indoor environments using their HVAC systems. These complex factors are quality of air and just figuring out the energy cost of this exchange process of clean air versus dirty air. Our consumer survey focused on 150 potential customers, and it's important to realize that a lot of them were also dental hygienists who helped us with the industry partnership and figuring out what the pain points were. 100% of these participants agreed that they needed a solution that needed more informed decisions, reduce the energy costs, and maintain a healthy environment for everyone in their building.
So with all the insights which we collected from our consumer survey, we also talked to industrial hygienists, and from years of research at lab of Professor Alexander Mamisev, we are building our solution software. Software combines power of IoT, machine learning, and AI to build data-driven intervention method, which can monitor aerosol concentration in real time, and it can alert users when the levels are high. So software smartly integrates into existing HVAC systems and sensors in the building. Data collected is transferred to our machine learning cloud, and user can then access data from web console or mobile application. Our mobile application and web portal is intuitively designed for the customer to get the exact feel of where the sensors are placed. They can import 3D blueprints of the building, and they can track exact locations and concentration level in real time. So we are focusing on developing novel data engineering techniques and to integrate active learning in our model. In our scenario, active learning will be very important because there might be drift in data based on season and also due to exposure from stressors like noise, temperature, and gas concentration. The insights which we generate are targeted towards when building engineers should let air in or let inside air out. Also, they will get more suggestions on actions which they could take to make this process more sustainable. We are also working towards integration with open source HVAC systems. There, our target will be to monitoring the health of the system, because if a subsystem goes bad, it contributes to large energy consumption and it is not good for our environment. Also, in short term, we are focusing only on the software, but in long term, we are also targeting the buildings with which doesn't have any pre-installed sensors. So we have partnered with GQ Electronics to work out a solution, and we will be building novel methods for exposure assessment based on real-time, hyper-resolved, distributed, low-cost sensor networks. The slide got stuck, sorry. Our aim is to reduce energy cost by 20%. We have validated this data through our experimentation in UW School of Dentistry, and initial results are very promising, and we are still working towards improving these numbers.
This creates value proposition for both the people inside the building, creating a healthier environment and bettering the productivity, but along with the enterprises reducing their workers' sick days and also reducing the penalties for OSHA and EPA assessments, along with the reduced energy costs through the HVAC automations. Right now, our target audiences are around educational institutions, enterprises, and hospitals, basically buildings that hold big populations and can easily transmit aerosols. Our revenue model can be envisioned here. Our first step is to do software as a service, and later on, partnering with GQ Electronics, we would go for a hardware and software service. Finally, for our competitors, one thing that sets us apart is that we have AI-enabled data analytics. And once again, our cost will be subscription-based and not produce thousands of dollars from the customers. Our market opportunity can be seen in this graph, where we are focusing on the CAGR margin of 6.31% from between 2019 and 2025 for control system market in the US. Our one-year launch plan milestones have been set up into 7 different milestones. And so we plan to release our beta release by June 18th and have our final product available by March 1st, once we've done some customer onboarding and user testing. Once again, thank you from our team and also from our mentors, which include PhD doctors from Alex Mamyshev to Seb Moscow, and the great guidance they've given us. Thank you from software team.
Fantastic, well done. Just shy of time as well. And we'll go 5 minutes for judges Q&A.
Can I ask a quick question? I don't know who would best be addressed to, but I think, the system I'm seeing, and right here, this picture is perfect, talking about the sensors. I assume the results of the testing of the air quality is only as good as the sensors. Over time, I would expect there's some degradation of the results and everything, that it's showing you. How is that going to impact what you're providing, and what would an end client need to be doing to maintain the system?
Yeah, so there are multiple factors, and we talked about active learning here. So drift can be because of sensor aging, and it also can be because of seasonality. So our algorithms are designed to factor those kind of drifts here. And Nathan, if you're here, you can take this question a little bit further.
Yeah, so one of the positives of the actual hardware is that it is very cheap to manufacture, right? So it allows buildings to have a whole system of sensors rather than just one expensive sensor, right? So these sensors are able to communicate through the cloud, right? And on the software end, we have an AI program that is monitoring these sensors, and it is able to determine when one of the sensors is starting to drift and will recalibrate the sensors.
At some point, when you say recalibration, is there manual intervention needed, or because I mean, if a sensor's clogged up or something's preventing it from getting good data, what happens?
Well, the actual sensor drift is all taken care of by software. If there's actual like hardware malfunctions, right, such as it getting clogged or the fan stop working, you know, manual intervention must be taken. But for the most part, it's just a matter of that sensor drift, right, which is, yeah.
Additional questions?
Yeah, on the slide that was a couple slides back where it showed kind of the competition and the different ways they're doing air quality right now from, yeah, where did you guys, I mean, how, is there going to be a tremendous cost savings here? That's one of your advantages also? Is that what you're estimating?
Yeah, one thing which set us apart is subscription-based model, and our sensors anyway will be a very low cost, and also software can integrate with existing sensor itself. So companies will not be bearing any hardware cost, and they will be paying a subscription cost which is based on number of sensors they have. So it is quite flexible based on their needs.
Okay.
Okay, final questions. All right, thank you, software.
Thank you.
Thank you.
All right, so we have got coming up next, so we'll get you prepared, Ecoelectric Automotive Solutions.
So my name is Benjamin Hansen, and as a mechanical engineering student working in the electric vehicle industry, I've thought a lot about ways to transition to sustainable energy for the least amount of effort and the least amount of cost. And right now there is a huge problem with the transportation industry. The average commuter spends around $2,600 annually on gas. And the problem is that the internal combustion engine cannot achieve an efficiency of much more than about 30% because of the Carnot cycle. Another problem is that renewables such as solar and wind energy are not able to be used on your traditional vehicle. Now, electric vehicles, on the other hand, can achieve an efficiency of over 90%. However, the high price makes them inaccessible to lower income consumers. The batteries aren't great for the environment, and there are certain cultural perceptions about electric vehicles. Your average redneck usually doesn't go out and buy an electric vehicle. So luckily, I've come up with a very simple solution. So we know that the majority of miles are driven within very short distances. So I've got here a graph that shows, these are all the trips, and this column here on the left is the trips less than 6 miles. So to make the biggest difference, you actually only need a relatively small battery range. So my proposition is to create a system that utilizes the millions of used vehicles on the road and turns them into plug-in electric hybrids. Now, the idea of a conversion kit isn't new. It's been done before. However, a few key differences that will help this plan to succeed where others have failed to gain much traction on the market are, first of all, I'm going to begin by targeting pickup trucks. Now, there are a few reasons for this. Pickup trucks are the best-selling vehicle in America. And second of all, it appeals to a different demographic than your traditional electric vehicle. And as you can see here, This diagram, I've got a motor hooked up. It simply gets mounted to the frame. One end connects to the engine, one end connects to the axle, and batteries can be mounted in a toolbox in the truck bed. This makes it so that on long road trips, you simply need to fire up the engine. You can drive as long as you want. But on your daily commute, where most drivers use most of their miles, they'll be able to run it on fully electric. Another difference is how we plan to reach the customers. There are currently thousands of dealerships in the US selling used vehicles. We plan to partner with these vehicles to give them a competitive edge as the demand for electric vehicles continues to grow. They'll be able to take their vehicles that come across their lot every day as trade-ins, and they'll be able to convert them to electric vehicles. Consumers, in turn, will then be able to purchase these vehicles and possibly even receive tax credit to help offset the cost. Now, of course, there is competition like with everything. However, the competition is a little different. Obviously, the Tesla and Nissan Leaf, they have a much higher price tag. And other conversion kit companies, such as EV West, target more towards the do-it-yourself car guys who are building hot rods or want a project. An example of our system, on the other hand, would be a $4,000 F-150 with the $4,000 conversion kit, totaling an $8,000 electric truck. And it's obviously going to appeal to a different demographic than other EV companies. On top of that, as a side bonus, the combination of the engine and the motor will add performance to the vehicle, giving it even more appeal to customers. The great thing is if we're successful, we'll be able to provide clean commuter vehicles to low-income blue-collar workers across the country, improve air quality, make it possible to use energy from solar and wind, and geothermal in your everyday transportation. Another advantage that helps us over other large startups is the fact that it relies on existing technology that's relatively simple. After we build our first prototype, we simply need to find the partnerships with the dealerships, and then we can start shipping them the hardware. I know this plan could have enormous potential, and if it succeeds, it will provide people all across the country with access to affordable electric vehicles. And that's all I got. So I guess we can go to questions.
Great, thank you, Benjamin. Questions from the judges?
I'm wondering if Benjamin, have you tinkered with trying to do any of this stuff on a old used car right now?
Mm-hmm. That's sort of what I'm working on right now is building this prototype. And I want to start with F-150s and Ford Rangers, just because they're very common. So that's sort of what I'm working on. It's not completed yet. I'm still in the design phase, but eventually getting my Ford Ranger to be built fully electric like this.
You're gonna add it to your own Ford Ranger?
Mm-hmm.
Oh, cool. When do you plan on trying to do that? Just wondering.
It'll be over the summer.
Oh, this coming summer?
Mm-hmm.
You'll have to take a picture.
All right.
Let us know how it turns out. Because I'm just wondering, like fitting the parts into the existing, into the frame and the drivetrain and all that kind of stuff. How challenging that will ultimately prove to be.
Yeah, that's a big part of the reason why I'm going with pickup trucks is because they have that long drive shaft and that room right there in the frame where a motor can be mounted fairly easily.
Okay.
Have you had conversations with dealerships? I guess specifically around, warranties. I guess used cars, that's less of an issue, but just about sort of how it impacts their sales. If that's who you're partnering with, how does adding your technology, which is not theirs, right? How does it impact their ability to make a sale to their customer?
So right now I'm more in the prototyping phase of that. I'm definitely planning that for the near future, but right now my focus has been more on getting the prototype ready so I can demonstrate it to the dealerships when I approach them.
Okay, sounds good.
Along those lines, have you seen any other hobbyists or people that retrofit do anything like this? Have you ever run across one on YouTube or seen anybody else or known a friend of a friend who's done it?
Yeah, it's fairly common actually, but it's more so the people that are kind of tinkering around in their garage, people just kind of building things on their own, not so much something that's readily available to the average consumer.
Right. Yeah, it seems like you got to be fairly resourceful to try and pull this off at this point.
Mm-hmm.
Final questions? All right, thank you very much. Well done. Judges will give you a minute to write down your notes. Well, up next, we've got Keith Sherman's team, followed by Earthen. Keith Sherman's team. Keith, are you here?
Keith is here.
All right, Keith, go ahead and feel free to pop up your screen there while those judges are writing notes. I will let you know when to begin. So just sit tight for me. All right. I've got a joke prepped, so I'm going to keep at it until somebody yells at me in the private chat. This one's pretty short, simple, and sweet. I don't trust those trees. They seem kind of shady. It's my dad joke. Okay. A few more seconds for the judges there. Okay. And then Keith, feel free to put that on presentation mode, the little icon just to the left of the slider down to the bottom right. Right hand side, other side. Yep, it's the little, yep, that's the one. Okay, we'll bring the judges back. This is AZSUV Inc. with Keith. We'll follow that by Earthen. And Keith, whenever you're ready.
Alrighty, so AZSUV Inc. is an energy storage and transportation technology company. Current battery technology is toxic, expensive, and potentially explosive. The mining process is invasive to the environment. E-waste is considered the fastest growing waste in the world. And when it comes to energy storage, really on a grid scale, dammed hydroelectricity is the largest form of grid energy storage, but with water insecurities and lack of universal geologically and geopolitically appropriate locations, that just is not feasible in a lot of different areas. And when it comes to battery technology, due to the potential buildup of toxic gases from overcharge and the need for deep cycle protection, current lithium ion battery technologies do require an expensive modern electronic monitoring technology that's, with the supply constraints with the chips and things like that, make it cost prohibitive and time prohibitive for applications. So who could benefit from this technology? Anyone who utilizes modern transportation technology could be positively impacted by our technology. In our technology, what we are developing is a aqueous sodium ion battery technology, which is non-toxic and non-flammable. In addition to our aqueous sodium ion battery technology, we are also creating patent pending technology, shear resistant energy storage, shear resistant and structural energy technology for individual, consumer, and military applications. So this is an example in construction of a saltwater battery, similar in construction to a lead acid battery, but without the toxic elements. We're developing patent pending software to communicate with original equipment manufacturer firmware. Our legal team is establishing AZSUV as an original equipment manufacturer for the auto industry, and we are currently in the prototype stages of our shear resistant, non-toxic, and non-explosive modular energy storage and structural capacity technology. So where can and what are the types of applications for the technology? So the application for our sodium ion technology can be everything from a home system to grid scale energy storage. And with the grid scale energy storage, the application I have found is a salt cave. So salt caves are currently used for petroleum, natural gas storages, but we could either create new salt caves or utilize existing salt caves to store the batteries that we are going to be using. And again, it's scalable for everything from a small home unit, and with the shear resistant technology, the applications can be automotive as well as military. So there are some companies right now that are producing sodium ion battery technology, but it's still very much in the developmental stage. One company, Blue Sky Energy in particular, does have commercially available products, but they are not available for the next 6 months to a year. So the novel application of this technology is the automotive sector. So what AZSUV currently does is we identify vehicles, primarily Ford Broncos, Ford Mustangs, and we remanufacture these vehicles, currently with internal combustion engines. However, we are looking to transition towards electric vehicles by utilizing existing battery technology and electric vehicle technology to be found in vehicles like the Ford Focus, the Ford C-Max, Teslas, things like that. But the reason why the Ford products have been identified is that the electric vehicle components can be acquired at a fraction of the cost of what new vehicles would cost. And the structural battery storages, think about the panels of the vehicle. So we're looking to replace the panels with structural storage, energy storage capacity, so that the panels themselves are not only batteries, but also created for safety reasons, for impact resistance, where when the shear resistance, when the batteries are impacted, they actually get stronger. This is just an example of a drive unit from a Ford Focus Electric. The engine, transmission, everything is there, and it can be had for $1,200, whereas comparable Tesla units are $7,000 or more. So the price when it comes to the vehicles, right now we're building essentially brand new internal combustion engine vehicles for $10,000 to $15,000 per unit. When we're looking to manufacture these vehicles with new electric drive components to integrate our battery technology, we're looking at a price point of $45,000. And when it comes to the actual locations where we want to be, we've looked at several different historically manufacturing sectors like Baltimore, Newark, New Jersey, places like that still have the infrastructure, access to the talent, but they are in an economically deprived situation that a large energy manufacturing facility and project like us could help to revitalize that area. So I'm a student, undergraduate student pursuing a degree in information science and e-society at the University of Arizona with a long history in automotive manufacturing and fabrication. And when it comes to my team, I'm still looking at bringing in some additional folks. I have some folks that are on board in advisory capacity, but not currently students. So that is AZSUV and our patent pending battery technology, scalable from everything from a home setup to commercial, automotive, on up to grid scale energy storage. So thank you for your consideration.
Great, thank you, Keith and AZSUV. Let's go for 5 minutes Q&A with the judges.
Hey Keith, this is Ryan. Can you help me understand? My limited knowledge is that this form of battery cells is not as good as the lithium, and I understand the drawbacks of the lithium with the danger and things such as that. But can you explain to me, my understanding is the sodium ion battery has that charge discharge. My understanding is it degrades quicker. And then also as far as the energy density, I thought that it was at a disadvantage. So can you maybe explain that in English terms, like with respect to range of a vehicle? What's your expectation if you could hit both items?
Absolutely. So you hit the nail on the head there, that the energy density, such as the weight of the battery, can definitely be a problem. However, that is offset by the fact that we're removing all of the internal combustion technology. And also when it comes to the truck applications like the Ford Bronco, Ford F100, F150, 300, these are trucks. These are vehicles designed to handle a substantial amount of weight. So the vehicle's already designed to handle a substantial amount of weight. And when it comes to the energy density of the sodium ion battery, that is true that it does not have the energy density of sodium ion. However, the energy density is substantially higher than a traditional lead acid battery. So by kind of finding the middle road between the weight and the cost as well, I mean, the cost to manufacture a lithium ion is substantially higher than the basic elements associated with a sodium ion battery. So the weight and the energy density is offset by the cost and the vehicle's ability to simply handle that weight. So also like for instance, the Ford Tesla Model X it weighs 7,500 pounds. The Ford Bronco in manufacturers, the way that it came from the factory, weighs about 4,800 pounds. So we're looking at taking out a lot of the internal combustion elements, replacing body panels with energy storage capacity. So yes, it is not as dense as a lithium ion. However, that lack of density is offset by the capabilities of the vehicle and the cost of the materials itself. I hope that answers your question.
It does. I just still worry. So when you look at this battery type compared to what Tesla has currently, let's say, and I have 5 vehicles, 4 of them run electric. On one of them, on the Tesla, they told me had it been created 2 months after, they used a lighter battery hoist or whatever you want to call it. That lost me 15 miles of range. So if I'm looking at your battery type, I'm saying in the future, if we're looking at that, because of your extra weight, I think we're going to get some range loss.
There definitely could potentially be a range loss. However, the offset of that density is offset by the lack of weight in the vehicle. So there's definitely some manufacturing to work out when it comes to that. However, the cost as well. I mean, a new Tesla is $100,000. We're looking at taking a already popular historic classic vehicle that will be appreciating in value and giving people the opportunity to drive that as their daily driver. So yes, there is density issues. However, this system that we're looking to design is modular as well, as so we could have some type of integration between lithium ion, sodium ion, things like that. That also the sodium ion technology, the vehicles is a novel application of the technology. It works as well or even better in some type of underground or residential, commercial, or grid level technology. The shear resistance is a novel application of the technology. There are substantial applications for military use as well, whereas the material, the battery itself, has a certain level of ballistics resistance to it. So.
Okay, we've got Earthen. We have a representative from Earthen here.
All right, I'm ready to go.
Okay, go for it.
Hey, thank you everyone for joining. We are Earthen. Our vision is to provide clean energy to everyone. I am Manas Pathak, PhD Chemical Engineering from University of Utah, pursuing my MBA from Arizona State University right now. What is the problem we are trying to solve? Well, wind and solar are nice renewable sources of energy, but they are intermittent sources, meaning you cannot have solar if sun is not shining, wind if wind is not blowing. So the solution is we could store energy when sun is shining and use it later when sun has set. Now, the problem can be in 3 categories: long duration energy storage, short, and seasonal. Department of Energy classifies long duration energy storage as Earthshot number 2, and this is the problem that we are focusing on, solving long duration energy storage. How do we solve it? Welcome EnergyPod, Earthen's patent pending carbon negative to neutral technology that takes excess energy from the grid, stores it, and dispatches it back to the grid for longer durations. I start from 6 hours plus when I say longer duration, but we can go all the way from 10 hours plus to 24 hours. Highly scalable and highly modular, no geographical or geological constraint in deployment of EnergyPod. The levelized cost of storage that we target is $40 per megawatt hour. Compared to lithium ion in 2025, that's going to be $100. We sell EnergyPod 1 megawatt capacity at $1.3 million with a 30% margin. What is EnergyPod? This is the double-clicking EnergyPod. You have 2 modular systems. One is called Energy Conversion Plant that sits on top of HPS, heated pressurized storage. ECP's job is to convert stored energy back to electricity. This is where patent pending IP comes into picture. HPS job is to store energy in form of heated, pressurized, supercritical CO2, which can be stored under the ground for gigawatt capacity or on the ground for megawatt capacity. It works very easily. At 12 p.m. in noon, when you have excess energy, give it to us. We will store supercritical CO2, pressurize and heat it inside the pod, store it for you, and then give it back to you, say at 11 p.m. by our patent pending conversion technology. Market opportunity. The overall global renewable energy market is $1.5 trillion TAM by 2025. We focus on the beachhead US energy storage market, which is going to be 8.5 billion worth by 2025. Long-term opportunities where entire states in the United States are converting and adding LDES, long duration energy storage, to their portfolio, and short-term opportunities where likes of Google and Amazon's are bringing the technology so that they could be 100% renewable and can achieve their 2030 vision. Revenue model, we sell energy storage as a service to utility providers like SRP, to enterprise customer like AWS, to solar and wind farm developers, and last but not the least, CO2 capture plants, which are very power hungry. The second category of revenue stream will come from capacity market and ancillary services. We are already talking to a local utility provider, and this is all backed by customer discovery calls. Competing techs, we do not compete with batteries. They die, lithium-ion die by 5 hours of consumption. We start off when lithium-ions don't work. Our competition is in this box, which is the plot of discharge time, how long can I discharge the electricity, and the size of the storage itself. We compete with pumped hydro and compressed air. Both have geological or geographical constraint. We took the best of both worlds and created energy part, truly 100% clean energy anywhere. Pilot to scale, how we will go there. Currently, we are raising 100K to demonstrate this technology. In 2022, we aim to pilot our first energy pod. There is the full mathematics in the model that says we will capture 10% of the $1.2 billion, $12 billion market in US by 2030. This is some of those charts that shows how we will get there. We will sell 900 units to get there. Each unit would be $1.3 million and 30% margin. Now, the payback for the customer is 5.5 years. Cumulative 100 years of energy experience in the team. I'm Manas Pathak, CEO. My CTO is also my PhD peer from University of Utah. We have leads and interns and 2 well-winning advisors. This is us. We are winning. We are, in bunch of competitions in top 20, top 30, RISE-B Plan, DOE, National Energy Storage Summit, and MIT Energy Week. We are winner of PSU Venture Devils, and we look forward to winning this competition today so that we can pitch towards demonstrating our technology. That is our next success. This is how we will define our next success in the short term. Thank you.
And thank you. Great on time. All right, moving right along. 5 minutes for the judges. Go for it.
Manas, can you clarify? So you mentioned energy storage as a service, but then you also said selling your units. Can you maybe clarify a little bit your business plan?
Yeah, so for those enterprise customers or like the small structures where there is only a megawatt level deployment, we could sell the energy part to be installed at their premises. For larger customers, where is a gigawatt levels energy storage requirement, like utility providers, we will not basically install it at their premises, but we'll sell it as a service. So we will have our own premises where we will install these series of modular energy parts and provide it as a service to the gigawatt level requirements.
So you would have units that you could sell, but then you'd also have essentially an earth end storage plant, for lack of a better word.
Yeah, we figured very quickly the beachhead we could go after is going to be either the enterprise small hospitals or enterprise customers or solar farm developers. So we are right now trying to do this pilot in 2022, which is not as a service, but selling that energy part, like piloting that energy part, which would be 1 megawatt capacity, and in an ideal world would be sold for $1.3 million.
Okay, and I apologize if I missed it, but the cost of a unit would be, do you have an idea?
Yeah, so it's 30% margin. So we are talking about like 926K or something like that.
Okay, thanks.
Question.
Questions from the judges?
Manas, can you just help me real quick on the payback period? You had a 4 to 4.5 year payback. What type of energy cost are you using though when you make that hypothetical?
So this was done for a local hospital in Phoenix. We took the cost of the electricity that they were paying and basically chopped off the peak cost that they were paying because we could help them flatten the peak cost. And that's how we calculated for this hospital 5.5 year payback. I would have to look back to understand what exactly they were paying.
Any memory on what they were paying compared to what the market is? Because energy costs obviously vary significantly state to state, and, you know, even company to company. I'm just curious because 5.5 is that's attractive.
Yeah, so we basically worked with them to get their, you know, the last 1 year of electricity consumption, and we took that price. I would be at this time, I'm blanking on it because the calculation was done somewhere late last year. I would have to look into my Excel sheet and find that information for you. I see if it's in my.
No, that's fine. I just was curious. I mean, if you're using real data from an Arizona commercial entity, that's all I would need to know. That's great.
So this was an overall $382, $382,000 per year energy saving, and that's how we calculated the simple payback. Again, it does not show the cost of electricity, and I don't want to say what I don't recall right now, but I can get back to you, Ryan. If you shoot me an email, it's in there.
All right, thank you.
Any other questions?
Oh, I saw in one of the slides, it said you're in negotiations with a local Arizona utility. So that would lead me to believe you've got some working prototype, or beyond that, some commercial ready.
Right. I think the bottleneck right now is demonstration. We haven't demonstrated physically, so that's why we are raising 100K. Once we demonstrate this, I think we are in good terms and pre-sales discussions to do this pilot. But I think we need to demonstrate first. And I think I'm talking to a few people and just basically raising that 100K. We have a cost sheet that says we could demonstrate this in United States, like in Arizona ASU's lab, for like 93K. So I don't think we will have pilot before demonstration.
Gotcha. Okay.
Looks like we have Nathan Dracobli's team. Okay, I see Nathan is here. Fantastic.
Okay, cool. Hi, so my company is called Invico. I'm an undergrad at Washington State, and my teammate, he can't be here right now, but he's current undergrad at Colorado. Yeah, nothing more to be said really about that. Yeah, so basically, basic problem, I think everyone's familiar with the carbon emissions, basically. That's a big problem. And our approach is more of an individual level approach. So one of the first problems we have with this is like measuring someone's carbon footprint from an individual perspective is like very time consuming and very complicated. And then going carbon negative on top of that is very expensive, and changing your habits is very hard. So essentially, yeah. And then, so our solution is basically we want to create a application, mobile first probably, where someone can basically take their financial footprint, looking at their assets and their, real estate and individual transactions, and basically giving them a carbon footprint score based off of that. And, and that the real benefits of that is passive, and there's no work needed beyond the initial thing. And then the big idea sort of paired with that is offering these tradable, tokenized sort of sequestered carbon assets, essentially. And the idea is we would create an asset backed by carbon, and that's tradable, and then can be sort of perceived. The idea is to get people to perceive this as a store of value that's competitive with traditional stores of value like cash and gold. Obviously, there'd be differentiations between that. But the idea is you wouldn't be exposed to carbon markets essentially as an individual. And so it would be useful for like offsetting while maintaining that stored value essentially. And then, so, so our next, and then with that carbon financial footprint sort of, I guess the core value proposition is obviously the passive carbon tracking, and then this carbon negative idea via the tokenization. But also, since we'll have all this financial data, our hope is that we can use this to basically assess credit risk for individuals in a different way compared to the traditional models, and that can have us have a competitive advantage over traditional banking. So yeah, and then I think the first markets we research or we're going to launch our credit card market, obviously, which is, and then carbon management market, which is 9 billion with the CAGR 6.2, and then credit card, which is 1 trillion, is huge. But obviously, banking is a huge industry. We'd obviously go after, I think this is more for westernized countries, and then Gen Z and millennials. And we made some assumptions, low end revenue of 134 million and high end rev. This is over a 5-year time frame, and then we have an average revenue of 26. Those are some broad numbers we kind of just pulled out. And yeah, and then our probably the most direct competition is Aspiration and Jura. These are two companies. Aspiration's a banking thing, but the key thing is they're just these startups that are sort of measuring carbon footprints. And then there's obviously the traditional model, and then there are also these sort of AI sort of credit risk adjusters like Upstart. And our sort of thing is combining all these factors and making it very easy for individuals to make these choices. And then sort of our business model is transaction fees, and then with credit cards, advertising, and and then eventually loaning. So yeah, using our models. And then on the broad implications are basically if you can get this to be an asset class, cryptocurrency is, I think, a comparable sort of comparison. If you are, with our assumptions made here, if you get people to see sequestered carbon as a store of value that's comparable to crypto, then you can basically pull, with our assumptions, we think between 5 and 440, we think maybe we could probably get between that for $1 essentially. And then, so we made those assumptions and then the IPCC has sort of predicted that we need to pull 661 trillion pounds over 2050 to meet those goals. So we think if we can make that would be, if we can make that a comparable thing, then that's sort of what the end result is. We can pull basically a lot of carbon and can be seen as a real asset class. Any other questions? I try to keep it broad, but we do have the technicals. Like I have projected financials, and but I just thought broad scope. That's the broad idea, and yeah, it's much different from what everyone else was presenting. But yeah, that's pretty much it.
All right, thank you, Nathan. Okay. Looks like we've got judges back. Judges, how'd it go? Some heated discussion there?
Yes.
Passionate and heated. If it's easy, then anybody could do it. But thank you so much for the time and for putting a lot of thought into it. Casey, how are we moving forward?
Yes, awesome. Well, thank you all for your patience. I'm going to toss it back over to Katie, who's going to announce some prizes first, and then we will announce the grand prize winner from this region after she goes through those announcements. Thank you all for your time. So Katie, you have the floor.
Great, thank you, Casey. Hi, everyone. My name is Katie Smith. I am one of the prize administrators with the National Renewable Energy Laboratory. I'm going to go ahead and announce the technology-specific semifinalist prizes. But before I do, I would just like to say all of the pitches today were wonderful. On behalf of NREL, as well as the Department of Energy, OTT, thank you for participating. We really appreciate all of the time and effort that all of the teams have put into their pitches. And we really encourage you to continue to move forward with them, regardless of what today's results are. So I'm going to go ahead. We have 3 technology semifinalists. So the first one is for the Building Technology Office, and that is going to Future Heat. So congratulations, Future Heat. The Fossil Energy and Carbon Management semifinalist is the Arctic Biotech Oath Team. Congratulations. And then finally, our solar semifinalist is the Earth N team. So congratulations to our 3 semifinalists for the technology bonus prizes. And we should be announcing on Wednesday which semifinalists are becoming finalists and advancing to the national competition. And for everyone, if you haven't already signed up to attend the national competition, it is taking place on March 24th, being hosted by Carnegie Mellon University in conjunction with CMU Energy Week. And I encourage you to attend to see all of the pitches that are there. The link to register is on the HeroX page in the timeline. So thank you so much, everyone. And thank you to UACI and our other regional conveners for helping to put today's wonderful event together. And thank you so much to our judges for taking the time today.
All right, and thank you, Katie. So I think Katie and Casey, that leaves us with one final bit of business. Is that correct? Which is the big winner announcement from the day. And just as we have seen from the rest of the time that we've spent together, I have a slide for that. Let me pull that up here. All right, and it says winner announcement. So I don't know how we do this on Zoom. Even 3 years later, I don't know how to do drum rolls or to get excitement, but it looks like the grand prize winner. Let's do emoji drum rolls, please. Hit emojis, hit $signs and money bags and thumbs up. Let's see them. There we go. This is as closest as we're going to get to a drum roll via Zoom. And that winner is Hawaii Innovation. Congratulations to that team. I don't, there we are. Okay, I see them in there. Well done, Hawaii Innovation, and thank you again to all of our judges for taking the time to really thoroughly deliberate on that one as well. And once again, I know we're just a couple minutes, but thanks again for attending. Congratulations again to Hawaii Innovation. We look forward to your presentation for the pitch phase of the competition. And thank you again to our partners, the Office of Technology Transitions, Exponential Impact, Portland State University, University of Washington, and Launch Alaska. So I'll wrap up just to say that, you know, truly special to have such a wealth of opportunity being provided by the Department of Energy and NREL. The way that they do this in partnering with organizations such as our incubator truly does put you at the center of creating the nationwide village that we need to create to really take innovations from the lab or the classroom and out into the marketplace, or at least to the benefit of society. For all you students out there, once again, you know, my resounding message to you is you're already taking, you know, the first right steps in participating in competitions like this and engaging with agencies like the Department of Energy and NREL. But please, if you are going to launch a company, make sure you don't do it alone. Take advantage of the support that's around you, and you know, make sure that that you use everybody you can as a resource. So again, thank you to those partners, and thank you to all of our judges today for spending some time with us and for contributing to what ended up being a great day and a day of at least learning for myself. So hope to see you all at the next one. And I think that'll wrap it up for us. Thanks, everyone.